Welcome viewers. In this video we'll discuss about Arrhenius theory of acid and base. According to Arrhenius theory of acid and base, acid is a substance which is capable of giving H plus ions in aqueous solution. Examples are HCl, H2SO4, HNO3, etc. HCl is an acid because it gives H plus ions in water. Base is a substance which is capable of giving OH- ions in aqueous solution. Examples are NaOH, NH4OH, etc. NaOH is a base because it gives OH- ions in water. However, some limitations are there. It fails to explain the behavior of acids and bases in non-aqueous solvent. Water is an aqueous solvent. Solvents other than water are known as non-aqueous solvents. So HCl is an acid in water. NaOH is a base in water. It fails to explain the neutralization reaction between carbon dioxide and calcium oxide. Carbon dioxide is not an acid according to Arrhenius theory. CaO is not a base according to Arrhenius theory. However, carbon dioxide is an acid according to Locke's flood concept. CaO is a base according to Locke's flood concept. CO2 is an acid because it can accept an oxide ion provided by calcium oxide. CaO is a base because it gives O2 minus the oxide ion. So neutralization between CO2 and CaO is according to Locke's flood concept, not due to Arrhenius theory. Similarly, neutralization reaction between NH3 and HCl cannot be explained by Arrhenius theory. It fails to explain the acidic nature of aluminum chloride, BF3, etc. These are electron deficient compounds. It cannot be explained by Arrhenius theory because LCl3 cannot provide H plus ion in water. However, LCl3 is an acid according to Lewis theory. It fails to explain the basic nature of ammonia, PS3, etc. PS3 is a base because it provides a pair of electrons, so it is a base, but it cannot give OH- ions in water. So PS3 is not a base according to Arrhenius theory. It fails to explain the independent existence of H plus ions. H plus ions never exist independently. H plus remain in association with water molecules, either one water molecule or more than one water molecule. If one water molecule gets associated with one H plus ion, it gives H3O plus, that is oxonium ion or hydronium ion. H plus never exists independently. It remains as hydronium ion, H3O plus. Let us explain Lowry Bronsted theory. According to Lowry Bronsted theory, acid is a substance which is capable of donating a proton. Proton means H plus. Base is a substance which is capable of accepting a proton. HCl is an acid because it can give H plus ion. But HCl is an acid in water but not in benzene because HCl gives H plus to water molecules and water molecule can accept H plus provided by HCl. But HCl is not an acid in benzene because benzene cannot accept the H plus ions provided by HCl molecules. So HCl is not an acid in benzene, but HCl is an acid in water. Base is a substance which is capable of accepting a proton. Then conjugate acid base pairs. Whenever a base is treated with an acid, another pair of acid and base is produced. NH3 plus water on right hand side, on the product side you will see NH4 plus and OH minus ion. NH3 is a base, water is an acid, and NH3 is converted to NH4 plus and water is converted to OH minus ion. NH3 is the base and NH4 plus is the acid. Here NH4 plus is the conjugate acid of NH3. Water is the acid over here and OH minus is the conjugate base of water. You see, acid is a substance, it gives H plus ions. The residual part after giving H plus is the conjugate base. If HCl is the acid, then the conjugate base is the Cl minus, because H plus is over here. H plus plus Cl minus gives HCl. If acid is weak, the conjugate base is strong. If acid is strong, the conjugate base is weak. Base is a substance which can accept a proton. When a proton is accepted by a base, the conjugate acid of the base is produced. If NH3 is the base, after accepting H plus, it becomes NH4 plus. You see, HClO4 is perchloric acid, the strongest hydroacid. H2SO4 is an acid in all cases, but in case of HClO4 and H2SO4, H2SO4 is a base. HClO4 is the strongest acid known so far. HClO4 provides H plus and H2SO4 becomes H3SO4 plus. In this case, H2SO4 is a base because it accepts H plus provided by the strongest hydroacid perchloric acid, and it becomes ClO4 minus. When H2SO4 is treated with perchloric acid, H2SO4 behaves as a base, not as an acid. You see, in this example, HSO4 minus can act as an acid as well as a base. If it is an acid, it gives H plus and the conjugate base is SO4 minus. If it is a base, it accepts a proton and becomes H2SO4.